In this lesson, we are going to learn about basic trigonometric ratios. Trigonometric ratios are a very powerful tool to solve for unknown elements of a right angle triangle. We just need to learn how to use this tool to answer some of the questions in mathematics which otherwise would be hard for us to answer. In order to define trigonometric ratios, we adopt a three-step strategy. For step 1, we'll name the triangle according to naming conventions if it is not already named. Step 2, we'll identify the hypotenuse, adjacent and opposite. And step 3, we will define the ratio. For naming this triangle ABC, the conventions suggest that we name this triangle ABC in anti-clockwise direction. So first, if it is A moving anti-clockwise, then will come B and then will be C. The side opposite to vertex A should be named with small letter A. Means the length of the side is denoted by small letters. Side opposite to vertex B will be denoted by small letter B, and the side opposite to vertex C must be denoted by small letter C. Once we have named all the three sides, next thing we need to know is which angle is under consideration. If this angle B is under consideration, let's name this angle as theta. We already have named the vertices as A, B, C. Now we named all the three sides of the triangle. These are called 6 elements of the right angle triangle. So we are done with step 1. And for step 2, now we need to identify hypotenuse, adjacent and opposite. And side opposite to 90 degree angle, which is C, is hypotenuse. So hypotenuse is again the side of the triangle which is longest, and it is opposite to 90 degree angle. Let me just indicate that with arrow. So that will be the side. Hypotenuse, it is not difficult to decide. Next thing is look in the right angle triangle and the side opposite to the angle under consideration, which is theta in this case. So look for the side which is opposite to theta. The side opposite to theta would be AC. This will be called opposite. So this is opposite, and the remaining side is adjacent. Let me call it adjacent. Adjacent. So our step number 2 is complete as well. First step, we need to name the triangle properly. Second, we need to identify hypotenuse, adjacent and opposite. Hypotenuse is the side opposite to 90 degree. Opposite is the side opposite to given angle, and remaining is the adjacent. And now we define trigonometric ratio like sine theta, cos theta and tan theta. Sine theta. Remember that sine is the name of this ratio, but it only makes sense if you apply this ratio against a given angle. If you do not mention the angle, the sign will never carry any meanings. Sine theta will be equal to opposite over hypotenuse, and cos theta would be equal to adjacent over hypotenuse, and tan theta would be equal to opposite over adjacent. This can be made easy to remember with the word SOH, S-O-H, C-A-H, T-O-A. SOHCAHTOA. SOHCAHTOA is a word generally used to remember that S for sine, O for opposite, H for hypotenuse, and then C for cos, A for adjacent, and H for hypotenuse. And now for tan is T for tan, O for opposite, and A for adjacent. So if you remember SOHCAHTOA, you will be able to remember the ratios for sine, cos, and tan. If you are given a triangle here, let's have a triangle and give it some values. Let's consider that we have this triangle with names as A, B, and C. This is angle 90 degree. This is 3. This is 4. And this is 5. If we name this triangle properly, 3 will be equal to A because this is a side opposite to vertex A, and 4 is side opposite to B, and 5 is side opposite to C. This is hypotenuse, and this is, if this is the angle under consideration. If the angle under consideration will change, you know that the opposite side will change. So first we need to consider the angle, which angle we are talking about. If the angle under consideration will change, then obviously the adjacent and opposite sides will change. So the side opposite to theta is equal to opposite. So this is opposite and this is adjacent. And if we were to define ratio sine, cos, and tan, then using SOHCAHTOA, S means sine theta is equal to opposite over hypotenuse. What is opposite? That is B over C. That is B over C, which is equal to 4 over 5. 4 over 5 because 4 is opposite and 5 is hypotenuse. Cos theta. Cos theta, which is adjacent over hypotenuse. Now what is adjacent? That is A, its value is 3, and hypotenuse again C, and its value is 5. So we can write it as A over C equal to 3 over 5, and tan theta is equal to TOA, means T for tan, O for opposite, and A for adjacent, and opposite is equal to B. So that would be B over A, and this is equal to 4 over 3. So this is the way we can define. There are reciprocal trigonometric ratios which are called cosecant theta, secant theta, and cotangent theta, but they are only reciprocal of sine, cos, and tan. So the reciprocal of sine would be denoted by cosecant theta, which is equal to C over B, and it is equal to 5 over 4. And secant theta, which is opposite of cos, secant theta, that will be equal to 5/3. And opposite of tan is cotangent theta, and cotangent theta would be 3/4. This is reciprocal of tan. So basic trigonometric ratios are sine, cos, tan, and their reciprocal trigonometric ratios are cosecant theta, secant theta, and cotangent theta. Simply by reciprocating, the sine ratio will get us cosecant. By reciprocating, cos theta will get secant, and by reciprocating, tan theta will get cotangent theta. Now the question is, what happens to these trigonometric ratios if angle will increase? If you carefully look at this triangle ABC, let's have a new circle here. So let's draw this new circle, and let's take a look that if this angle theta will increase, if this angle, this was angle theta, but if now theta will increase and this point will come right here, then what will happen is, let's say that this will be the new hypotenuse, and if we draw the perpendicular, then this will meet the base here at this point. So what happened, this was A, this was B, this was C. What has happened is hypotenuse is still same. Hypotenuse is still same, but the opposite side has increased. If the angle increased from theta to a bigger angle, which is alpha, then this new height is bigger than the previous height if we increase the angle. So if central angle increases, opposite increases, and if opposite has increased, then the adjacent has decreased. Adjacent decreased. You can see that BC is smaller than the triangle when angle was smaller. So the adjacent is decreasing as the angle is becoming bigger and bigger, was just within first quadrant, and the opposite is increasing. So if opposite is increasing, now what will happen to sine? Sine theta, which is in fact equal to opposite over hypotenuse. Now you can see that the numerator is getting bigger and bigger if theta is increasing. So this is increases, and cos theta, which is defined as this, cos theta, which is equal to adjacent over hypotenuse, because this is opposite is adjacent is decreasing, so the numerator is becoming smaller, so this is decreasing, so this decreases. And tan theta is equal to opposite over adjacent, opposite over adjacent. Now the numerator is increasing, the denominator is decreasing. So this is increasing at a faster rate. Increases at faster rate. But this is only true in the first quadrant. Our discussion is limited so far in the first quadrant only. So in this lesson, what we have done, we have defined trigonometric ratios, basic trigonometric ratios, sine, cos, and tan, and we have also defined their reciprocals trigonometric ratios, which are cosecant, secant, and cotangent. And we also know that in the first quadrant, when angle increases, sine starts increasing with increasing angle only in first quadrant, and cos theta starts decreasing as angle becomes bigger and bigger, and tan theta increases at much faster rate, because for tan theta the numerator increases while the denominator decreases. So tan theta increases as a much faster rate. See you in the next video.